Welcome to this Wheatbiome project webinar. The Wheatbiome project is related to unraveling the potential of wheat microbiome for the development of healthier, more sustainable and resilient wheat-derived food and feed products. And today we will talk about feed. This webinar is included in the Practice Abstract 3, oriented to farmers and feed industry. The title of this Practice Abstract is New Formulation for Poultry Feed via Fermentation by means of recirculation. You will know that byproducts from the fermented wheat beverage production industry can be an interesting alternative to enter into rations for chicken. This use could reduce environmental footprint for livestock production and perhaps obtain poultry meat with differential value. Who knows? To talk about this situation, these possibilities, we have three interesting people. On one hand, we have Lucas Wozniak. He's a member of Wheatbiome Consortium. He's a member of the Institute of Agriculture and Feed Biotechnology in Warsaw, Poland. Later on, we will have Pedro Cordero. He is president of FEPAC, the European Feed Manufacturers Federation, and vice president of CESFAC, the Spanish Feed Manufacturers Federation. He will talk about feed and possibilities in the industry. And at last but not least, we will have Javier Garcia. He's researcher in animal production in Polytechnical University of Madrid. He will talk about the technical and scientific view of these possibilities. First of all, we have, as I told, Lucas Wozniak. So, Lucas, welcome. Good morning. How are you?
Hello, everyone. My name is Łukasz Woźniak, and I'm representative of the Institute of Agricultural and Food Biotechnology, which is located in Warsaw, in Poland. I would like to tell you a bit about fermented wheat byproducts and its possibility of using it in poultry feed, present you the current state of art. And at the beginning, I must admit, I'm not a practitioner myself. I'm rather a scientist. So it will be from this one specific perspective. I don't have chicken at my home or at my farm, so it's from other perspective, but I hope it also will be interesting for you. I would like to start with the context of the work and the rationalization of the approach. Generally, poultry production is highly dependent on the feed, which is mainly produced using grains, corn, or sometimes wheat, barley, but mainly corn, looking at it worldwide, and the protein source, which is very often soybean meal, but also meals from other oily crops like sunflower. Together, they made up the majority of the diet, which is usually around 70%. These ingredients account for the most of the production cost, making the farming and keeping the poultry very sensitive to the fluctuations of prices of grains and of soy and of protein crops. Additionally, as coronavirus situation showed us, we are also susceptible to logistics, to problems with suppliers, etc., etc. And of course, our birds need to eat, so we cannot tell them that they need to wait one more week for the feed. At the same time, processing of grains, and in this specific case of a wheat, produces large quantities of byproducts, and three most important are bran, germs, and distiller grains. They are often underutilized or sold very cheaply as a byproduct. Sometimes they are included in, for example, in food matrices like bread, but it's very region dependent. We have some of such products in Poland, but for example, when I was in Spain, I haven't seen such products. Using these byproducts directly is difficult because they have high fiber content, some anti-nutritional compounds like phytates, and the quality can differ from batch to batch. But there's a possible solution, fermentation technology, which can somehow upgrade them, improving nutrient availability, reducing unwanted compounds, and creating value-added feed ingredients. Now, a few words about the wheat. It's the second most cultivated cereal in the world, and it's a staple food for human consumption in most of the Europe. Now, not that much because we also have a lot of corn, but historically, it's the most European of the grains, we can say it. During the milling and subsequent production, only about 3/4 of the grain it comes to the flour. The rest is usually considered as a byproduct. Now, some definitions. Wheat bran is the outer layer of the grain, which is rich in fiber and phenolic compounds and unfortunately phytates. It's around 15% of the grain's mass, and as I said before, it's produced in large amounts during milling of the flour. Wheat germ is it's like an embryo of the wheat, and it's produced in rather small proportion because it's 2 to 3% of the grain mass, and it's high in bioactive compounds like vitamins, antioxidants, as well as proteins and oils. Wheat distillers dried grains are residues from production of bioethanol, but also for like the consumption of ethanol, let's name it some liquors or vodka. So it's a bit different industry that we are taking from, but the main crop is the same. They contain concentrated protein, fats, fibers, so a lot of nutrients. But again, we have the high variability on the nutrient content depending on the technology used. All those products are abundant and inexpensive. However, there are some limitations in their direct use as a feed. Now, maybe a few words about fermentation as general. It's a biotechnological process that uses microorganisms, usually yeast or bacteria, to modify some ingredients of matrix, improving their nutritional value and adding functional properties. In other food industry branches, we of course have alcoholic fermentation producing wine or beer. We have lactic acid fermentation producing sauerkraut or kimchi, etc., etc. We use fermentation in the production of biogas. We use fermentation in production of vinegar, etc., etc. So even if for some people it might sound maybe not strange, but a bit hazardous for food as a food that it's fermented. It sounds almost like it's rotten or spoiled, but it's generally very widely used process, and it's really well known. Looking from the industrial point of view, we have two main methods that can be applied. Solid state fermentation, which is used, for example, to production of soya sauce, when we have substrate that are only slightly moistured and cultured with microorganisms like Bacillus, Aspergillus, or lactic acid bacteria. Other type, submerged fermentation, which is generally in liquid state. We have a large or sometimes even maybe small tank, which is aggregated, which the medium inside is aggregated. We put there, sorry, We put there our byproducts, we put there a lot of water because we need to work on liquid media. It's easier to control the process, but on the other hand, the product must be additionally cleaned because all this water needs to be taken away before using it as a feed. Generally, during the fermentation, anti-nutritional factors are reduced, while enzymes, organic acids, and probiotics, so these beneficial compounds, are generated. As a result, we have ingredient with a higher digestibility, more available nutrients, and potential health-promoting effects for animals. Of course, it requires us to include one more step in this production, but in some cases, it's worth it. Now, a few words about the mechanisms of action that we expect in fermentation. Fermentation breaks down complex fibers such as cellulose or arabinoxylans into smaller fractions, making the nutrients more accessible. Phytotannins or certain phenolics are degraded by bacteria and their enzymes, which on one hand changes taste, which is also important, maybe not that much in case of poultry, but more in case of, for example, swines. Additionally, as we don't have those antinutrients, phosphorus, calcium, and other minerals are easier ingested from food. Fermented products often contain enzymes, organic acid, and microbial biomass that enhance digestion. Generally, especially when we use lactic acid bacteria, we expect lowering of pH during the process and production of short-chain fatty acids, which promotes intestinal microbiota and strengthen gut barrier function. In some studies, we have observed that fermented wheat bran stimulates immune system of poultry. Now, a bit more about exact results from poultry studies that were described in the literature. The first statement says that it was usually the bran is used because on one hand it's the easiest to obtain in big quantities, and it's generally is considered a good material because we can also think about some other byproducts like a straw, which is generated on the field, but its nutritional profile isn't that good for poultry. We had a study that said that inclusion of 5 to 10% of bran increased average daily gain by 4 to 8% and improves the feed conversion ratio by 3 to 5% compared with control diets, and it's of course connected with broilers, so the meat chickens. Fermented wheat bran was associated with taller valley, deeper crypts, and higher values to crypt ratio. So we're talking here about the gut morphology, which is a bit more specialistic. So I won't get deeper into it. Increase in beneficial bacteria and reduction in pathogens, also inside the intestines of the chickens. Higher antibody levels as a result of the changes in microbiota. Positive effects are consistent at the modest inclusion levels from 5 to 10%. At high levels, results are mixed because at this point we're giving the chickens a lot of the fiber, so it can somehow hinder the absorption of other nutrients. So they're just like colloquially speaking, a bit stuck with this. The literature also shows tests on some other animals. As I said before, swines are very potent animals to be fed with fermented wheat byproducts. And as in case of poultry, we've observed that 5 to 10% of the share of fermented wheat bran seems like optimal level. Experiments on ruminants such as cattle, sheep, and goats also showed some interesting results. There were also performed experiments on rabbits in agriculture and even on using as a feed for companion animals such as cats and dogs, but here it's very, very limited. So basically we're focusing on swines and on poultry. Now some practical considerations to think about when you're thinking about implementing fermented wheat bran or other fermented things in the diet of your animals. And recommended inclusion at the most effective level of 5 to 10% of diet. Of course, at the lower levels, we won't really see any effect because it's too little. On higher levels, the amount of fiber in the bran can hinder the growth of the animals. Form: wet or dry. Generally, wet products are more effectively acting, but on the other hand, dry forms are easier to store, transport, mix with commercial feed if it's only a part, and they're much more resistant. So it's like when we talk about the best before date, so it's like our shelf life of those feed, it's like 1-2 weeks versus half a year. Enzyme supplementation, so using additional enzymes such as xalanase or phytates can even further improve the digestibility of the nutrients. Quality control, as process bases on living organisms, it doesn't have to always go the same way. So the quality control is also, of course, on the side of the producer of the fermented material, not on the side of the farmer, whose possibilities are very limited. So here is the recommendation to analyze of the protein, fiber fractions, and availability of the minerals in the fermented material. Additional thing, we also encounter it in our works that high inclusion levels can lead to problems with pelleting the material. Economic aspects are that fermented wheat products are low-cost alternative to conventional feedstuff, and they can be used to somehow reduce our dependence on corn and soybean meal. Now, a few words about the limits and research gaps. First one, standardization needed because fermentation protocols vary widely, and the final product quality can be really inconsistent. Age-specific effects. Young chickens are more sensitive to high fiber feed constituents, so generally we should avoid giving it to very young birds. So as I said before, we can observe the hindering of their growth. Long-term safety, especially in the case of wet feeds, we can observe mycotoxin formation, contamination from other microbes, and general lack of stability during the storage. We also have at this point, limited data of scalability of the process and its environmental impact. Now going slowly to the end, some conclusions. Fermentation adds value. So even if we need to put additional effort, additional process into our production chain, we can, using fermentation, upgrade the abundant and inexpensive byproduct into good ingredient for feed of poultry. Benefits of performance. So improved growth, improved feed efficiency, better gut morphology, and immune responses, which can translate into healthier poultry. And good health and nutrition is the same as I said before. Success depends on the proper fermentation protocols, quality control. We cannot focus on it too much. Appropriate inclusion levels and enzyme supplementation. So it's not easy way, but when we put everything on the right place, it will work. They're not limited into the poultry, also other animals. And as we reduce reliance on the corn and soybean, we contribute to more sustainable animal production. That's all from my side. Thank you very much. I hope you enjoyed it, and thank you very much once again.
Thanks a lot, Lucas, for this vision. And now, as I told before, we have Pedro Cordero. As I told, he was the president of FEFAC, the European Feed Manufacturers Federation. Good morning, Pedro. How are you?
Good morning. I'm Pedro Cordero, FEFAC president. FEFAC is the European Feed Manufacturers Federation, and I also part of FEFAC as one of the vice president. And my role in a normal life, let me say, is part of Nutreco Group as institutional relationship and strategy in Nutreco Iberia for Spain and Portugal. Today, I would like to introduce you an interesting Horizon Europe project called Wheatbiome. While the project is a broad scope, has deeper explanation, require higher technical knowledge, I will focus only on that questions that are directly relevant for you. The future of poultry feed and how microbial innovation can create new opportunities for the feed industry. So the main goal of the project is, as far as I understood, is to design and develop new formulation of poultry feed through fermentation, using mainly wheat byproducts and other suitable food industry residues to improve animal health and the quality of poultry feed, poultry products, eggs and meat. Let's talk before about some question that can be interesting for all of you about the vulnerability in Europe. The feed and livestock production on the value chain is currently highly vulnerable in Europe due to their significant exposure to major cost drivers. We cannot forget that the feed represents between 40 and 80% of the total production cost for livestock and fish farming, depending on the species. 40% for ruminants because the use of raw fishes, and 80% for monogastric mainly. In addition to that, the European agri-food competitiveness is also challenged by strategic dependencies from third countries, especially for soya and essential feed additives as vitamins and amino acids. Europe is capable to produce only 80% of the vegetable proteins to cover the needs for the entire livestock production. And we can not forget that the feed industry are feeding millions of animals every day in Europe, and we are part of the food chain. So our role is really, really relevant and strategic. This is something that we want to remark as much as possible every day in our speech and meetings. One of the core aspects of this European vulnerability is the high dependency of imported micro ingredients, for example, the soybean meal, which are essential in feed formulation as the major source of high protein components. Between 35 and 55% of the crude protein contents come from these high protein products. And let's say that over the past decade, the European dependency of this kind of products, it's roughly 75% of these high protein feed materials, with soybean meal alone is representing a 97% of import dependency rate. You know that mainly we import soybean meal and soy from Brazil, Argentina, and the US. Despite the past improvements driven by the European biofuel policy, which is the main source of product ingredients, rapeseed meal, sunflower meal, and DDGs, in the recent years, we have seen a stagnation in local protein self-sufficiency as a growing trend in corn and soy imports, further highlighting the exposure to price shocks. Shifts to a global trade policy and sustainability-related disruption. For example, everything related with the Ukrainian war and retaliation of tariffs on soy and corn, and potentially and deforestation regulation. Talking about microingredients very shortly, we import 80% of the vitamins that we need and 95% of the key amino acids, lysine or tryptophan. Majority of them are coming from China and other third countries. This dependency also represents not only an increasing risk of supply chain disruption and price fluctuation, but also the ability to feed the animals with a balanced diet. We cannot forget that the essential amino acids and the proteins are not 100% available, and ensuring animal health and probably animal welfare status. Of course, we can force the use of more soy or imported proteins to compensate these essential amino acids developments, but it is also affecting to the cost and status of the animals. If any of these countries decided to stop to deliver to the EU some of these products, or any other unexpected phenomenon happens, or climate phenomenon or wars or whatever, will result in a lack of supply of these products, which in extreme cases could lead to vitamin deficiency or high-value protein products efficiency, affecting to our feed industry and at least to the farmers, potential losses the farms. This is why all the initiatives, as the project that we will talk about right now, focus on developing the new protein alternatives within Europe is more than welcome. This is our view. We are talking about wheat, one of the world's most important crops, which huge volumes of byproduct generated in milling and processing. And many of these materials are underutilized and treated as low-value waste. The project, as far as I understood, aims to transform wheat byproducts into innovative, safe, and sustainable fermented quality feeds for poultry, improving animal welfare, and contributing to circularity of the production in the agri-food sector. This is one of the key topics, as you know, in the European agenda. So, what is the key message I received during the lecture of the documentation I received? Is the first one is unleashing the hidden potential of the wheat microbiome in promoting a healthier and more sustainable feed development is one of the key messages. A comprehensive soil to fork approach to explore how biotic and abiotic factors affect wheat microbiomes and overall wheat quality, which is important also for feed production. And let me remark, especially the three last points I want to talk is health, sustainability, and circular economy as probably the most key elements for the feed industry, in my view. Talking about sustainability, wheat is a cornerstone crop facing major challenges. We are suffering, you know very well, climate change impact, global population growth, and soil degradation. We cannot forget that 75% of the European soil are under risk. And the project supports the European green targets addressing the soil restoration. Sustainable farming practices are tested as well, as I read in the papers, and perception of citizen and food system actor microbiomes are also analyzed. Finally, assess environmental and economic impacts on soil treatments and fermented products. Talking about the health, fermentation processes are investigated for their ability to reduce the gluten-related peptides linked to celiac disease and to generate bioactive compounds contributing to public health and by tackling autoimmune disease such celiac, which affect around 3% of the European population. And finally, as I refer to you at the beginning of my speech, it's a circular economy. The wheat byproducts are upcycled to tackle the food waste and in line with the circular economy principle. Let's say that circularity is one of the main key attributes of the feed industry. We are the champions, let me say, in the circular economy because we are using in our formulation every day thousands of tons of volumes of byproducts in our formulation at factories with a very successful history. I don't want to stand too much about the status of the project. Of course, there are more technical questions to talk and people with more knowledge than me to explain. But I also want to only summarize the 3 or 4 small details. The project is under selection of microorganisms, the fermentation optimization process, nutritional safety profile, detailed analysis of protein, vitamins, fatty acids, biotic products, and mainly robust safety checks of contaminants, which is important, of mycotoxin and heavy metals, which is one of the more relevant parts for the feed industry, because you know we are always checking and testing the question related with the feed safety materials. And finally, the most important thing is to validate in practice. Trials in laying hens and broilers should be done, and the project also look at good health and microbial resistance. What is important and what is the benefit for the feed industry? Let me summarize in four main elements of topics. The first one is cost efficiency, because through the valorizing local wheat byproducts, we can reduce reliance on imported proteins. So it is one of the main topics and the main challenge that we have as a sector, as I explained at the beginning of my intervention. Second one could be product differentiation. Fermented feeds can be marketed as natural, functional, and sustainable, appealing to farmers, retailers, and consumers. Why not to use these attributes to make a differentiation of our products? The third one is animal health and productivity. In product, as I also mentioned before, in good health, reducing mortality, better conversion feed rate, and higher quality eggs and meat, which is a very relevant topic. And finally, once again, the circular economy positioning. I don't want to insist too much. So, in short, Wheatbiome looks like it's not only a scientific project. Let's say this could be a business opportunity for the industry, helping the sector to secure local circular raw materials, which is relevant, enabling the development of a next generation of functional feeds, which is also important, and strengthening the role of feed manufacturers as key players and sustainable agri-food system. You know that our sector is always under big pressure due to our direct relation with the livestock production in Europe. This is something under discussion every day. So as much as possible, as much as we can, to demonstrate that we are a reliable business, a reliable industry, sustainable and circular, etc., we could have better options to keep the future of our industry healthy. In the current status of the project, as far as I understood, are moving from laboratory prototypes to validation in animals, which is a very interesting process. This is the right time for feed companies to look at this innovation, explore collaboration, and think about the future of market application of these kind of products. So, thank you for your attention. I look forward to discussing how Wheatbiome can add value to feed and poultry sector in the future and the near future when all the trials and results are published and shared with the industry and the sector. Thank you very much for your attention.
Thanks a lot, Pedro. It's an interesting view. And now we have the third person in charge in this webinar, Javier Garcia. Javier is, as I told, he's a researcher in animal production in the Polytechnical University of Madrid. Good morning, Javier. How are you?
Thank you, Jesus, for your invitation to stay with you today in the framework of the Wheatbiome project. Let me introduce myself. My name is Javier Garcia, and I am professor at the Agricultural School of the Universidad Politécnica de Madrid in Spain. In the next minutes, I will talk about the nutritional interest of co-products of the wheat fermented industry. First, I will talk about the chemical composition of wheat. Next, about the fermentation process. I will continue with the chemical composition and nutritional value of residues of wheat fermentation, and I will conclude with final remarks. As you know, the most important part of the wheat grain, or the major part of the wheat grain, is the endosperm, accounting for around 80% of the grain. It contains most of the starch of the wheat grain. The second part would be the outer layers, accounting for around 14% of the grain. And these outer layers are constituted by mostly by the insoluble dietary fiber. And finally, the germ accounts for around 3% of the grain and contains most of the lipids. Accordingly, the main chemical constituent of wheat grain is the starch content, around 60% of starch. The second one are crude protein and insoluble fiber, accounting for 10-11% respectively. And finally, much farther from these constituents, we can find a small proportion of sugars and lipids. All these constituents sum around 96%, indicating there is another 3-4% not included in this analysis, and probably are associated with the arabinosilans and beta-glucans content of the wheat grain. Wheat grain shows a great variability when we take samples, for example, in Spain, more than 8,000 samples. The starch content varied from 58 to 64, 8% units. And although the most usual content is around 60%, as I commented before. And concerning crude protein, it varied from 9% protein to 14%, 5% units. Although the most usual values are around 10-11%. What are the uses of wheat for fermentation? There are two main types of fermentation. The one produced by Saccharomyces, by yeast, to produce ethanol or to produce beer, and the main co-products obtained are constituted by the insoluble and soluble residue. These co-products are usually found in the animal feed industry, like the dry distillers grains with solubles, DDGS, or wheat brewers grains. The second way to ferment wheat is using lactic acid bacteria to produce wheat fermented juice, and in this process we obtain mainly as a co-product an insoluble residue, but not a soluble residue because it is usually combined with the fermented juice. What are the factors conditioning the chemical composition and nutritional value of the residues of wheat fermentation? First, the chemical composition of raw wheat, and we have to consider the variability I commented before. The second one is the fermentation process. The characteristics of this process, mainly the temperature type of inoculum, if we use bacteria or yeast, and the length of fermentation. And finally, it is also important to consider how the sample, how the residue is dried, and what type of residue is included in the final co-product, only the insoluble fraction or both insoluble and soluble fraction, because it will condition the nutritional value of the co-product. When we ferment the starch of the wheat grain, the starch disappear, and the rest of the components will be concentrated around 3 times. For example, as content by 2.7 times, or crude protein, or lipids, or insoluble fiber, or for example, soluble fiber, while starch content decrease more than 16 times. This means that the final co-product, in this case DDGS from wheat, is concentrated in crude protein and insoluble fiber. And of course, this means that when we use this byproduct in poultry nutrition, for example, the energy content is much lower because there is no starch. For example, the metabolizable energy for poultry of wheat is around 3,100 kilocalories per kilo, while that for DDGS is only of 2,100 kilocalories. That means that we have lost 1/3 of the metabolizable energy with this fermentation. In contrast, we found that digestible protein is concentrated, and in wheat is only of 9.4, and it increases in DDGS almost to 29%. Just a comment about wheat protein, the amino acid profile of this protein is not the best for animal feeding and have to be completed with another sources of protein. There are other byproducts like brewer's grains. The problem of brewer's grains usually is the high moisture content that contains, and it means that mostly this co-product is used for ruminant feeds, ruminant farms near the factory that produce this co-product. Sometimes the factory, the beer factory, dry this co-product, and we can obtain a dry brewer's grains. And in this case, we also find a co-product very rich in insoluble fiber and crude protein. So rather similar characteristics that we found in the DDGS of wheat. What are the constituents of the final co-product? If it contains only the insoluble fraction, the main chemical constituents are the structural carbohydrates and lignin, the insoluble protein, and the undegraded starch, but in a very small proportion. And if it contains also the soluble fraction, it will contain also organic acids, soluble fiber, soluble protein, vitamin B, for example, and microbial residues. Just to conclude, a final remarks, the nutritional quality of these co-products depends on the fermentation residues included. These co-products are really interesting for animal feeding, and they are usually included in diets for pigs or for ruminants. But we have to consider that these co-products supply less nutritive or energetic value than wheat. One important issue is that in the last years, it was stressed that poultry requires a minimal dietary fiber, and these kind of co-products and other technological fibers may have an opportunity in poultry diets. In this context, it's important to consider that particle size of the final product may play a role. Finally, it may worth studying the physiological effects of other minor constituents of these co-products, like the bacterial cells or organic acid, that may exert a positive effect on the animal health. Okay, that's all for me. Thank you very much for your attention.
Thanks a lot, Javier. And this is the end of this webinar. This is the pre-results information. So you will know about us later, and because we have the results next year. And if you want to get more information about the Wheatbiome project, you can check the website wheatbiomescriptproject.eu. Okay, and there you have the information, and you can ask questions if you have anyone. Thanks a lot for your vision, and see you in some time. Thanks.